Hi, good day. I am Nicole Mae Sumalta.
I am Airene Mae Supilar.
I am Joana Mae Auza.
Hi, I am Jundel Silvano. Reymar Orlasan.
Here to present the given problem, and the given problem here is that a sinusoidal wave is propagating along a stretch that lies along the x-axis. The diagram shows that the displacement of the string as a function of time is graphed in for particle at x is equals to 0, which is the red wave, and x is equals to 0.900 meters at the blue wave. In this problem, we are going to answer the several questions. First, letter A, what is the amplitude of the wave? We are going to find the amplitude of the wave using its formula. Letter B, what is the period of the wave? Letter C, we are going to determine the wavelength and the wave speed running to positive x direction. So we will going to find this. And letter D, we are going to determine the wavelength and the wave speed. And this time, it is running to x direction using the same formula. So the last question that we are going to find is that we are going to defend this. Would it be possible to determine the wavelength and the wave speed with that points are x is equals to 0 and another is x is equals to 0.900 meters. So that's the problem that we are going to solve.
And today, I am
Identify the problem and the formula to be used.
There are couples of equations that we need to use. One is that the frequency is equal to the reciprocal of the period, and likewise the period is equal to the reciprocal of the frequency. The other one is that speed is equal to the wavelength lambda times frequency f. If you combine these two equations, you should be able to convince yourself that lambda can be written as the velocity of the wave times period.
set of the problem.
So in part A, we were asked about the amplitude of the wave, and that is simply the maximum displacement of the wave out from its baseline.
So as we can see from the diagram, the wave goes in between positive 4 and negative 4. So, as we all know, amplitude in physics is the maximum displacement or distance moved by a point on a vibrating body or wave measure from its equilibrium.
So in part B, we were asked about the period of the wave, and period is the amount of time it takes the wave to complete one full cycle.
So if you look at time 0.01, we have the crest in the string we're at maximum displacement of 4 millimeters. And the next time this point achieved a displacement of 4 millimeters is at 0.05. So the formula for this would be time is equal to the displacement, the final displacement minus the initial displacement. So the given for the final displacement is this. .05 minus the initial displacement 0.01. We were told that the point here is x equals 0 and the point here is x equals 0.09. They were in the same wavelength. So we were asked about the speed of the wave and the wavelength of the wave. The formula for this would be speed is equal to the distance it travels divided by the time that it elapses minus 0.01. The answer would be 0.09 divided by time that it elapses, which is 0.35 minus 0.01. So for the purpose of figuring out its wavelength, we are going to multiply the V that we got here to the time
For part D, calculation is quite similar to part C, but instead of moving to the positive x direction, we are going to the negative x direction in finding the wave speed and the wavelength of the wave. The formula of the speed would be v is equal to the distance it travels divided by the final time minus the starting time, which is 0.09 divided by 0.05 minus 0.035. So again, the formula for the wavelength is lambda equals the speed, which is the answer for this, times the time, that is the answer from the part B. That would be all for the setup of the problem.
Execute. This day, I'm going to execute the given formula to the various questions.
We're given a diagram that describes the motion of the wave, and we need to use this diagram to answer those various questions about the wave. The first question we're asked of what is the amplitude of the wave, and that's simply the maximum displacement that was achieved from the baseline, which is 4 millimeter amplitude. So for the part B, we were asked about the period of the wave, and the period is the amount of the time it takes the wave to complete one full cycle. So the period of time, 0.05 seconds minus 0.01 seconds. Period of the time now is 0.04 seconds. Now, in part C, we're asked about the speed of the wave and the wavelength of the wave. Velocity now is that 0.09 meter, and we divided by the time that lapsed, which is roughly 0.035 seconds. This y times x, time, is used to describe the displacement of individual particles in the medium. Equals the amplitude sine 2 pi times the reciprocal over the period times x over the wavelength. The peak at time is equal to 0.01 seconds is the first maximum for x is equal to 0. And the same time, peak at x is equal to 0.09 meter that occurs at the time, which is 0.035 seconds. So let us solve now. Or this is 2 pi times 0.035 divided by 0.04 minus 0.09. This 0.035 is a time, as well as the 0.04 is a millimeter, and the 0.09 millimeter also, that was divided to the wavelength. It is equal to pi over 2, or our wavelength is equal to 0.14 meter. This is our answer. And our velocity is equal to frequency times the wavelength, which is 25 times 0.14. It is equal to 3.5 meter per second. So this is our answer for the letter C. For the letter D, we're asked that instead the wave is moving in the x direction, determine the wavelength and the wave speed. Y times x in time is equal to amplitude sine times 2 pi times the reciprocal divided by the period plus x divided by the wavelength. After this, so the peak at the time is equal to 0.05 seconds is the part maximum for the x is equal to 0 and the same time at x is equal to 0.09 meter occurs at the time is equal to 0.035 or the 2 pi times 0.035 divided by 0.04 plus 0.09 divided by the wavelength is equal to 5 pi over 2 or our wavelength is equal to 0.24 meter and our velocity or the speed is equal to frequency times the wavelength. Is equal to 25 times 0.24 is equal to 6 meter per second. So this is our answer for the letter D in 0.24 meter. For the last question, our answer is no. It is not possible because we cannot determine which peak is the consecutive peak. So we cannot determine the time between the two peaks of the 2 points.
And I'm going to evaluate the problem in figure E15.11. Therefore, the amplitude of the wave as shown in the solution was 4 millimeters, and the period of the wave was 0.04 seconds by subtracting both crests in the sinusoidal wave. The wavelength and the wave speed with the waves that moving in the positive x direction was determined as 0.14 and 3.5 meter per second in velocity, with its 2 points, x equals 0 and x equals 0.0900 meter, within one wavelength. While if the wave was moving in the negative x direction, the wavelength and wave speed was determined as 0.24 meter and 6 meter per second in velocity, within the given 2 points, x equals 0 and x equals 0.0900 meter. In determining the wavelength in part C and D without given 2 points was resulted as not possible, considering that in order to get the wavelength of the waves, it needs to have given point to perform the calculations.
Thank you and hope
Thank you for watching and listening.
We would like to acknowledge our physics instructor, Mr. Sanan M. Patresio.